as he said, my name is Michael Plaster. I'm the remote monitor specialist. And to get started, I wanted to hope everybody had a good holiday and let you know my family told me that no more dad jokes over the holiday. Well, I can't stop cold turkey. So they'll get better from there. All right, our agenda today is why does AC matter? AC coupon sizes. We're going to talk about getting your current density off your Bullhorn 4210 or 4250, and then manually calculating the AC current density with your Triton and Triton coupon. All right, so why should we care about AC? Well, prolonged AC interference will rapidly accelerate corrosion on your pipeline. Exposure to unmitigated AC currents can cause damage to coatings and metal loss. And then high induced AC voltage presents a shock hazard to pipeline personnel. If that is not enough, there's regulations on it. The PHMSA 192-473 has been modified to reference the AC interference as well as the mega rule. So for the regulations, each operator needs to have a plan that will affect to minimize the stray current on your pipeline and also to correct any instances where it is greater than 100 amps per square meter. But then the kicker comes in where they say that if it impedes safety operations on the pipeline or adversely affects the environment or the public. So that leaves it a little wide open there. So we're going to go ahead and get started by talking about our remote monitors a little bit here. Our RM 4210 is our satellite version of the AC monitor, and our RM 4250 is our cell version of the AC monitor. And these will monitor your native coupon, your reference cells, you'll get your AC current density, you'll be able to get your pipe to soil, and you can also use our Triton test station or our Triton coupon. One of the advantages of using them all together is the ease of the installation. It's all color coded, easy to get installed. It's pretty much plug and play. Now, the most common question we get into support on our AC monitors is how do I install my remote monitor? No, that's not it. It is how do I manually read AC current density, because we've made it pretty easy to do the install of the AC monitors. The question comes afterwards is how do I verify my readings that I'm getting on the Bullhorn unit? And that's what we're here to talk about today. So first thing you're going to need to know is your AC coupon size that you have out in the field. We commonly sell a 1 centimeter squared, a 10 centimeter squared, and a 1.4 inch inch squared coupon. And so which size should you use? Well, the standards don't specifically tell us, but we suggest the 1 centimeter squared. And the reason for that is you want to use a smaller coupon to take that AC current density, because as you get in those larger coupons, such as 100 centimeter squared, there's a spreading resistance. And over time, that makes your reading, manual reading, a little bit inaccurate. So you want to use those smaller coupons, and you need to know the size of that coupon. I'm going to stress that several times throughout this presentation because that we get a lot of questions on, as I said, on how to calculate the AC current density. And when we ask, what's your coupon size? I don't know. Well, we can't do that. That's part of the calculation. So we have to know that coupon size. So, and for testing your current density, first thing you need to do is have something to compare it against, and that's your bullhorn reading. So when you go out to the field, you're going to swipe it with a magnet to open up the Bluetooth on it, and then you can open up Bullhorn Tools. Bullhorn Tools will take a reading on it, and you can get your Triton AC current density. The reason you want to do this before you take your manual reading is if you go off a reading that you had on the Bullhorn web from a month ago, a week ago, even yesterday, it's not going to compare to the reading you take today. The current density can change hour by hour and sometimes minute by minute, depending on the current you have on the pipeline. So you need to compare apples to apples. So take the Bullhorn reading with Bullhorn Tools first. All right. Now, in this scenario, we're going to show you how to take a reading manually. So the first thing you're going to do is disconnect the RMU. This will take any of the impedance that are combined with the voltmeter and the RMU. So then you're going to hook up your DVM to the AC coupon in the structure. Once you've got that hooked up, you're going to flip the switch to open. And the reason you want to do this is to avoid interference from the DC coupon. If you are hooked up to it, you can see your reading changes when you flip it from closed to open. The reading you get when it's open is the reading you want to use for your calculation. Once again, needs to be open. And as I said, I'm going to keep stressing this, know your coupon size. All right, now we're going to go through several scenarios here. Our first scenario is manually calculating the AC current density using a 1 centimeter squared coupon. Our manual reading, we're going to keep consistent through all these scenarios of 27 milliamps and a coupon size of 1 centimeter squared. We've got our formula written out there for you, and if you don't want to write it down now, we'll provide the presentation for you later so you can get that formula. As we plug in our information there, we're going to start out with our manual reading over the coupon size. And we get down to step 4. It's going to be your 27 times 10 will equal 270 amps per square meter. You're really cooking on your pipeline right there, but we're going to come back to this reading in a few more slides here. But we're going to move on to our next scenario. But before we do that, I want to tell you about the knock-knock joke. The guy who invented the knock-knock joke should get a Nobel Prize. All right, I said they would get better. All right, we're going to move on. Our next scenario is a 10 centimeter squared. In this one, we're going to change it up a little bit. Our 27 milliamps, we're going to convert that to amps. So it makes the formula flow a little bit better. You could leave it in milliamps if you want. And once you get down to step 4, it's going to be 0.0027 times 10,000, which gives you 27 amps per square meter. So big difference, same reading between two coupon sizes.
Hey, Mike, real
yes.
quick, Ryan Simpson was asking if the AC coupon is normally connected to the structure with a Triton configuration.
When we take it at our reading, that's when we connect it up. Other than that, it's disconnected up until the time we take our reading. All right, in our third scenario, we're going to use a 1.4 inch squared coupon. And this one's a little more involved because we have to convert the inches to centimeters squared. And I've got that here in our formula already calculated out for you, so you don't have to do that in the future. So we'd put our 27 milliamps over the 9.032 centimeters squared. And when we calculate that out, what we'll end up with is 2.989 times 10, which gives us 29.89 amps per meter squared. So 3 different scenarios, and I want to simplify all this for you there so you don't have to always run through all of these calculations. It's pretty easy to do here. If you've got a 1 centimeter squared, taking a milliamp reading, you multiply it by 10, and that'll give you your current density. If you got a 10 centimeter squared coupon, you just multiply your milliamp reading, or take your milliamp reading and it's 1 to 1. So if you're taking a microamp or amp reading, just convert it to milliamps and it's a 1 to 1 scenario there. Your at 1.4-inch squared coupon, that's a little more involved, but not too much. You have to take your milliamp reading, divide it by that 9.032 times 10, and that'll give you your amps per square meter. But if you look at these 3 coupons, we got 3 different readings uh, for the same milliamp reading to start out with. So that's why the coupon size is very important. If you don't know your coupon size or you guess at it, you could have a reading that is way off. If you think it's a 1 centimeter and it's actually a 10 centimeter, that could drastically change what you do as far as mitigation going down the line. So you need to know that coupon size. All right. In conclusion, want to start by checking your reading with Bullhorn tools off your Bullhorn RMU, whether it's a 4210 or a 4250. Need to take that reading while you're in the field. Don't take that reading off the Bullhorn web that's from yesterday or last month, last week. You need to have something to compare it to that is apples to apples. And directly taking that reading off that Triton coupon will help eliminate your IR errors. It's a lot of the questions we get about the readings that are taken above ground and not using our Triton coupon. And you need to make sure that you flip that switch to open to eliminate your DC interference. You will, as I said, if you're taking your reading out there, you'll see a lot of times the difference between the closed setting and the open setting. And then you definitely need to know that coupon size. If you don't know that coupon size, it's going to change your reading. Now, if you've got a Bullhorn RMU connected up to it and you don't know that size, you can look on Bullhorn Web and see what it was originally configured with. But if it was something that was buried years ago by another technician, unfortunately, you're going to have to find that paperwork on that coupon before you can calculate your AC current density. And for this envelope, you can push it as much as you want, but it's still stationary. All right. Any questions?
Yeah, we have a few minutes left, so if anybody wants to unmute themselves or just post a question on the chat, we'll be able to answer that for you.
I'll jump in here. First of all, I'd like to tell you that your jokes are terrible, which makes them awesome. The question I have is there any way, or do you have any plans to automate, further automate the technology so that, let's say, within the database, you'll be able to populate the coupon size, and then therefore, when you take the manual reading, it would automatically do the processing and calculation in the field and give you your amps per square meter as an output?
That we're going to have to check with our product managers on to see if that, because we are looking at doing some changes in the future, but I'm not sure if that's going to be one of them, but that is definitely something we can consider. We definitely have the coupon size on the website. So it's something that we can get to if we need to. And also with Bullhorn Tools, as you dig into your channel settings, you can see that as well. But to add a script to manually calculate that reading, that's something we can look at, because that's something that's definitely could see using that in the future.
Okay, thank you.
And Brad, the other side is, you know, if you guys are using, so in PCS 2.1, we added all of the specific AC calculated fields for like field data collection when you're out on site. So I think part of the question would be is, have those been activated on your device as well? Because that's also where you're going to see your coupon size, and it does do some calculation work, but it's something we can take offline with you just to make sure that you have things activated, because sometimes that's been missed. Like in the past, people had to use like UDFs, user defined fields, in order to build out some of these advanced calculations, which we did resolve back in 2020. So and maybe it's something we can take offline and see if there's a solution for you.
Okay, I'm a consultant, so I have different clients. So I don't know what they have. Yeah, I know that they've got certain things in their database system that they download into the field computers before they head out. So, but I don't know what. So
a lot of times we that's something you can call into us, ask, and then we can work with your end user in order to let them know what fields to physically activate for that inspection, which means you'll see those populating on your data collection device when you're out in the field as well. So anything we can do to help be a middleman to get you the best fields and the data collection stuff, we're happy to help.
okay, thank you.
Right. Any other questions? Anything we can help to answer?
I think I see a couple of questions in the chat in here. One from Ryan Simpson. Wait, no, Jerry actually was the first one who asked another question. It seems nothing changes when I flip the switch when hooked up to measure AC current density. And David Monroe also said, I have the same issue as Jerry. When I toggle the switch, nothing happens. The AC coupon is not connected to switch. Do we need to swap the wires at this point?
On that one, I'm going to have to check on what's causing that. I know on low current, it doesn't really affect it, but I need to check and see what may be causing that on if you've got higher currents out there.
And David, we'll do a follow-up to any questions around this, and we send that to the group. So we'll actually get answers for you. We do that as a follow-up of anything inside of this chat. I also see Nick, PCS 2.5, our new release, with some key more automation-based functions, is going to be releasing to the public on December 16th. So we do have the release notes, and we can send that out to this group as well. And I'll send it directly to you, Nick. So I'll take care of that on my side.
Looks like that's all the questions we had in the chat. Any additional questions? Now's the time to ask.
I guess I'll jump in. This is Jerry Wismer. I asked that question about the nothing happens. And then Ryan Simpson, if you want to go off mute, you put the AC coupon is not connected to switch. So if that's true, that would explain why the flipping the switch doesn't change my readings. But does that mean that flipping the switch is just what Mike was saying about reducing any DC interference that might be in the read? I don't feel like I'm getting good reads.
Yeah. Oh, go ahead.
Go ahead, Mike. I say, hi, Jerry. I'm Cole. I'm product manager for Triton and Bullhorn and everything. I'm just hopping in here. Yeah, what Ryan said is correct, because when you flip the switch, you're removing any DC interference on the AC coupon. So that would be why the AC coupon is not directly attached to that switch. That's just removing any DC interference from the test coupon that we have on the Triton. So since you have the native, the test, and the AC coupon, it'll be removing interference from the test DC coupon.
Thank you. That explains a lot.
Of course.
Derek, we can follow up with you to help with any type of things if you're feeling like the reads aren't reliable. You know, we definitely have a lot of best practices there, and we can jump on a support call, but we'll follow up with you directly after this as well, just to make sure that we're doing
Okay.
to support you.
Sounds good. That's the main reason I joined this was to figure out, you know, why isn't anything changing when I flip the switch. So that explains a lot. Then I will call AI because I have put together like a sketch from how I understand everything, all the way from when you order a Triton coupon test station, what it looks like when you get it, versus how you're supposed to hook everything up with the RMU. And that little black cover that's on that Phoenix cap over the wiring harness, there's a little black pin device that shorts wires number 1 and 3. I didn't know until playing around with things and figuring it out that you have to remove that to season the coupons and then put it back on if you're not going to use an RMU. Does that make sense? If you know what I'm talking about. They come
Yeah.
from the factory with that little pin cover.
Yeah, that definitely makes sense there. So yeah, we've had a lot of questions on that in the past, and I can also send you the write-up we have on it as well.
Beautiful. Thank you.
All right. Well, we'll go ahead and start to close things down. Obviously, happy to answer questions. Again, any questions you have, any need for support, you know, always have your account managers, support at aiworldwide.com. I mean, we'll be able to turn things around as quickly as we can to help answer, and always want to be a resource for you. So I hope you guys have a really great end of the year. We really appreciate all of the effort and partnership throughout 2024, and are really excited for a really strong and great 25. So thank you again, and hope you guys have a great end of the year and holiday season. So
Yes, and a couple of reminders before everybody jumps off. Stay tuned for some more details on the 2025 Virtual Brew topics. We'll be releasing those soon. We're moving to a new platform, probably in January, but you'll get some reminders and such. We'll make sure you get some communications on when that does happen. And we'll send a follow-up after this. Usually it's on Monday. We send an email with resources. We'll send a copy of this presentation. So feel free to reply if you have any additional questions then as well. Thank you so much, guys. We'll see you at the next one.